All right. So the way I'm gonna structure this is we're gonna now go back to word problems. Well, not go back, but we're gonna go word problems, and I'm gonna start with one inequality first, and then we're gonna build more and more, just like we've done so far, right? We started with one inequality, and then we did systems. So word problems, I step back a little bit. We just do one inequality, and then we build our way up to the system, okay? So word problems involving inequalities. Okay, that's the topic for today. When given a word problem, you'll have to read and interpret the question in order to produce the inequality or inequalities presented to you. Okay. Things to keep in mind. Type of data, right? You can have discrete and discrete data only exists in whole numbers, are only available in whole numbers, right? So example, people, right? Coins, cans, etc. Right? So number of things, number of items. You need to just read the question and know, right? This is definitely a discrete, so you'll have to round, right? So if it's discrete, if data ends up being discrete, you will need to round the POIs, right, to whole numbers. That's very important. So we will state them like we always do, but then next to it, we'll say, okay, from now on, we're going to work with the rounded values. We're not going to work with the decimals, right? If it's in fact discrete, which a lot of the times you'll find is going to be the case. Okay. The other option you have is, anybody remember? Continuous, yeah. Continuous data, right, exists as decimals, fractions, slash fractions, sorry, that I meant to say decimal slash fractions. In other words, you can use partial quantities. I'm just going to do that, quantities, just to make it fit there. We can use the corner points as is, right? Use the POIs as is, right? I guess I didn't give you examples for continuous, but it could be hours, distance, temperature, anything you can measure is continuous, right? Anything that can be measured is continuous. So we got that. Oh, money. I should add money because that's important. We'll do a lot of questions involving money. So obviously money is all good, right? We can do partial, right? So that's one thing to always keep in mind. And then the next one is the our domain and range. What? I thought we were never going to talk about that. It's okay. We'll do more of that when we do quadratics. Almost all cases involve data that cannot be negative. Therefore, your graph will most likely only appear in quadrant 1. So I will put this next to this in brackets, contextual, right? If there's a text involved with the inequalities you're graphing, if it's a word problem, it's most likely going to be in quadrant 1, okay? And so I'll give you a graph here. So if you have a ruler, it'll probably work. So we're going to do two graphs side by side to give you a good visual here. You have your x and your y axis. And if you have different colors, it'd be great. You don't have to. But let's say you have a graph where one line goes like this. And the other line, let's make it go like this. And for this particular instance, right, just go ahead and go quadrant 1, quadrant 2, quadrant 3. We don't have to use Roman numerals, right? Quadrant 4. And I'll make my solution be right here. So I'll write down solution here on this little wedge. And I will shade everything around it. So below the red and above the blue. Just light, you don't have to shade it too much there. If you look at that right now, how many corner points do you have here? Just one, right? So in this particular case, there's no context here, okay? No context, right? Therefore, only one POI, or corner point. Okay, and that corner point, we can use an arrow, right, just to tell ourselves that it's right there. There's only one corner point here. So that's what your calculator is going to do every time, right? It's going to include all quadrants. As soon as it becomes a word problem, if I told you, hey, wait a minute, there's actually context involved with your variables, you're now limited to just the first quadrant. Okay, so let's make that copy. I will just copy the first quadrant over to the right. X and Y. The red one ended up like this. And the blue ended up like this. My solution is here. And let's shade in this part right here, this little triangle. And we shade in everything above that. This is only quadrant 1, and this has a context around it. You can say word problem. If that word throws you off, that's just saying it's a word problem. Okay. Now you have more than just one corner point. So let's make sure they stick out. So there's still this one here. And then you have this one here and this one there. Three POIs, right? And this is because the X and the Y axis act as lines when it's a word problem. Okay, so that's going to be the main difference. If I just give you a bunch of inequalities, no word problem, you do as before. You use all 4 quadrants. But when we do a word problem, then that's different, right? So I will just maybe just highlight no context, and there's a context there. So that's the biggest change for you. to know, and you will know that if there's a word problem, you know. I don't have to tell you a whole lot. I apologize for the all these graphs, but I feel like if you're a visual learner, this is going to help you determine that. See the difference, I guess, right? Okay, let's do a little bit of terminology here. Turning words into inequalities. In this case, we will let x be the number of people. And yeah, we'll just leave it at that. How about this? Y will be the number of pets. There we go. So if it says, if you read a statement and it said something like this, no more than 40 people allowed in a room, right? But you just focus on the no more than 40 people. We'll write that down. Let's keep writing down at least 10 people room can hold 50 pets. Committee needs a minimum of 35 people. Stadium can accommodate 30,000 spectators. I'll just go people, it's easier. That can see up to 24 pets. Hold on. Facility can hold a max of 100 people and pets combined. So how would we now translate that? And we already determined, right, that X is number of people, Y is number of pets, right? We've already determined that. So no more than 40 people. So obviously we're talking about the variable x, and we're saying that this can be no more than 40. So that it has to be less than, can it be equal to? As long as you're not more, it's okay to say equal to. So that would be less than or equal to 40. So you just translated the words into an inequality like that. Okay. At least 10 people, at least says that x has to be greater or equal to 10. A room can hold 50 pets. Oh, we're talking pets. So we need to use the variable y. So if a room can hold 50 pets, how else can you say that? It can hold up to, right? If you see the capacity, it says that's how many can fit in there. So y would have to be what? Less than or equal to 50, because you can't have more. You can have 50 exactly or less, but more than 50 is not good. A committee needs a minimum of 35 people. You're talking people. Minimum means that that has to be greater than or equal to 35. Are you catching on? All right. Yeah, go ahead. A stadium can accommodate 30,000 people. So we're talking people. So if this is the number of people, that has to be less than or equal to 30,000. A vet can see up to 24 pets. We're talking pets up to 24. So as long as it's less than or equal to 24, you're good. Facility can hold a max of 100 people and pets combined. Now that one is going to be different. How would you state that? X plus y. Oh man, have you taken this course before? X plus y. This combination would have to be less than or equal to 100. Got it? So that's exactly what we're going to do. We're going to build like that. Unfortunately, I don't have any less than. Okay. So obviously less than would be very obvious, like it has to be like if it said a vet can see less than 24 pets, right? It would just be, it would not have the equal sign. But for word problems, most of them are equal to. 99% of the time you will see that, okay? All right, let's keep going. Steps involved. You're gonna have to write a lot. So if your hand is hurting, stretch it out a little bit, right? Because these steps are to help you, okay? And they will translate to everything we're doing. So steps to interpret and graph inequalities, right? Sorry, word problem. Sorry, guys. To interpret and graph word problems involving IQs. Okay. So steps to interpret and graph word problems. So the first thing is you need to do is introduce variables. Introduce, right? So basically what you're going to do is you're going to say let x be the first variable and let y be the second variable. And it will be pretty obvious when you read the question which one is which. Okay, so that's the first step. The second step, state the implicit constraint. State the implicit constraint. What is that? Implicit is it's not obvious, it's not explicit, right? Like it's kind of like you have to assume that that's true. State the implicit constraint / restriction. Okay, and this goes back to like this. So we'll say x is greater than or equal to 0. You close it like that, you put squiggly brackets, and you also write down y is greater than or equal to 0. Or make it even easier, you just go x comma y, both of them are greater than or equal to 0, whichever one you want. But this is basically you have to state that because that's what we're assuming is true for most of our examples. So don't forget that, because a lot of students lose marks. Even when I ask that, they're like, I don't know, just leave it blank, right? So don't forget that. And number 3 is write the inequalities presented. Each restriction mentioned, comma, should be represented by an inequality. So if they have a restriction on money, there should be an inequality that takes care of money. You can only spend up to $1,000, right? If there's a restriction on space, there should be an inequality addressing the space, the square footage. So look for those keywords, and I'm going to teach you how to do that. I'm just going to leave it at that. I will sometimes use a chart, but not always, for graph the inequalities in step 3. But remember to only graph in quadrant 1. Do not extend lines past it. If you extend the lines past the axes, you're going to lose half a mark, okay? So make it stop, don't continue. I know I always tell you don't be scared to extend, but now that we're doing word problems, you got to stop at the x and the y axis. Do not continue, okay? 5th point, state the coordinates of all points of intersections. And I will say this, surrounding the solution. This is going to be a new word here, solution polygon. What? A polygon is just a many-sided shape. So, right, sometimes it's a triangle, sometimes it's going to be a trapezoid looking thing, sometimes it's like a sliver. So you need to just, that's why I use polygon as solution region. It's the same thing, right? Solution region. I should say go back up to 4, use reverse shading, because it's a system, so I'm assuming you use reverse shading. Most of the time it will be a system, so you want to use reverse shading. So step 5, we're taking care of that. I need to add something to 5 here. I ran out of room, so I'm going to continue on the back side of this. We good? Man, I love you guys being in the classroom, not at home, because I can tell when you're done writing. Okay. 5 continued. Right, 5 continued. If data is continuous, leave POI as is. Right? If data is discrete, write rounded coordinates next to it. Don't just overwrite, but just put it right next to it. Example, let's say you have a corner point that happens to be 4.25 and 714. You would put next to it like this. You round it to 4 and 7 if it's discrete. Okay, so that's what I want you to do if that's the case. And let's do our first problem now. Stretch once. There you go. This will take, like, if you have 3/4 of a page or something, you should be fine fitting in the whole example, including the graph. Example 1. A certain manufacturer makes scarves and toques. It takes 15 minutes to produce a scarf and 10 minutes to produce a toque. The company has up to 2 hours of production time available. Graph the solution set showing all possible solutions. It's just, I'm using fancy wording like the textbook will. It's basically just create a graph which shows all the shading and everything like that. Okay? So I'm basically going to walk you through the steps here. First of all, usually in within the first sentence you will be able to tell what your variables are. So what do you think are the variables x and y here? Scarves and toques, exactly. So scarves and toques, I'm going to just let my audience know, right? Let X be the number of scarves, and let Y be the number of toques. Done. Okay. My second step is the implicit constraint. And it's obvious that both of them need to be positive, correct? There's no doubt about that. What kind of data are we talking about? Discrete or continuous? Discrete, right? You can't make part of a toque, right? So discrete data, you just make a note of that because later on that's going to help you when it's time to state the corner point and it happens to be a decimal. Okay, so that's my second step. The third step is to come up with your inequalities, right? And so there is a restriction on what? On time. There's a restriction for on time. So let's highlight that. I'm going to go back up to this and say you have up to 2 hours of production time. Okay? So you can write that down. You can, with that, come up with your inequality, right? There's a restriction on time. And there should be an inequality for that. We know that it takes 15 minutes to make a toque. So it takes 15 minutes to produce for every toque you, sorry, am I getting that right? Scarf. It takes 15 minutes for every scarf you produce, and it will take 10 minutes for every toque you produce. So that right there, this statement right there, if you were to plug in the number of scarves and toques you made, it would give you the total number of minutes you used, right, to produce them. And this has to be what? Less than or equal to, what am I going to put on this side? 2 hours. And that is what? How many minutes? Yeah, you have to have the same units, okay? You have to have the same units. So we're going to put 120 minutes. So now it's all in minutes. Okay? So this is your inequality, that this is a restriction on time. And so if you graph it, you would make sure that you stay below the 120. Are there any other restrictions right now? They don't tell you how much you're supposed to make combined. They could say, hey, we want you to make at least 50 toques and scarves combined, but they didn't say that. Okay, so let's go ahead and graph this. Is that step 4? Yeah, it is step 4. What quadrant am I in? Quadrant 1. So that'll make it a little bit easier for sure. And you don't use X and Y. We now go number of scarves. And here we go number of toques. And I kind of, knowing that I have enough room, I will just do the steps that I used to do with you. So the x-intercept and the y-intercept. So I end up with 15x is equal to 120. Divide both sides by 15. X is equal to 8, exactly. So it's 80. The y-intercept is 10y is equal to 120. Divide both sides by 10. Y is equal to 12. 0, 12. Beautiful. No decimals even. So this step, you still continue to do that. And then rewrite it, because later on you're going to have to do that. So 10y is less than or equal to negative 15x plus 120. Divide everything by 10. Y is less than or equal to. You can leave it like that if you want. I should have done this before I started my axes. I kind of got carried away a little bit. I apologize for that. So this is solid, comma, true is below, right? And so I will shade above. So I'm going to use that. So if I think about it, right now I only have one graph, so you can just go ahead and graph this. So I'm going to make sure 8, 0 fits. So I'm going to go 2, 4, 6, 8, 10, and so forth, right? So 2, 4, 6, 8, 10, 12. I'm going to label every other one. That'll give me enough room to fit that in, but don't cram it too much, okay? On my y-axis, I need to make sure I have enough for 12. So you might want to go 2, 4, 6, 8, 10, 12. So it does work. For me, it works. For you, it might not. So you might have to go up by 3, so whatever. And so 8, 0 is right there. 0, 12 is right there. It's a solid line. Do not go past. Right? This line is y is less than or equal to negative 15 over 10, x plus 12. Sorry, plus 12. I'm going to shade above and just shade lightly, okay? Don't cross off the labeling and stuff like that. But I need to be able to see the shading though, that being said, right? You still write solution like you always did. So nothing really changes. Once you have the inequality, you do the same as before, but you stick to quadrant 1. Okay? One possible solution. What could be a possible solution what could be a possible combination that would work? Would 4, 4 work? It's in the solution region. Absolutely. 4, 4. And what does that mean? Producing 4 scarves, yeah. Don't mix them up, right? Scarves and 4 tubes. We can check 15x plus 10y is less than or equal to 120. We go 15 times 4 plus 10 times 4. And so that is 60 plus 40. 60 and 40 is 100. And this is true. So you can check by looking at the graph, or you can check algebraically plugging it in and going with it. Okay? Page 7 and 8 in that booklet, and I will show you that in a bit. There's a bunch of one-liners, not big word problems, just one-liners. And I need you to do what we did here with all of them. Go through the motions. I will post the key for you, graphed and everything. Watch what it says here. Follow the instructions carefully, right? give one sample solution for each question, plug it in and show that it works. I need you to do that as well. And other than that, just go through the steps that I've talked about today. Tomorrow I'll do a short mental math. I call it mental math. It's just an AC. It's going to be short, okay? Based on this. Based on this stuff, yeah. You're still using your calculators, yeah.